Chapter 6, Lipids, page number 94, those who have the textbooks. Okay, so we will discuss later. Those who are joining late, we'll discuss later about this discussion that went right now. Okay, with Dr. Mittal sir. So those who are joining late, please help them out with the page number and the chapter name. It's sixth chapter, Lipids, page number 94. So lipids, or can also call it as fats. Okay, lipids is any various organic compound that are not soluble at all in water. They can be soluble in ethers, okay, other compounds, other organic, inorganic compounds, but not in water. That is what lipids are. Okay, this includes fats, waxes, oils, hormones, okay, and other certain compounds of the cell membrane as well, and they function as the energy storage molecules. Okay, they give you high energy. Lipids, fats, 1 gram of fat gives you high energy, more than what carbohydrates can give. Okay, and these are chemical messengers. Fats are subgroup of lipids called triglycerides. So this is how a lipid structure looks like. See, this is the biphosphate layer. Okay, so here you can see two layers are there. There are two hydrophilic layer and two hydrophobic layer. Okay, so hydrophilic layer is the one that is attracting water. Okay, these circles that you see on both the side, hydrophilic, they attract water. Okay, but the hydrophobic layer, they do not attract water, they repel water. So what happens because of this attraction and repulsion? Am I audible to all? Just give me a moment. If I'm stopping the video, am I audible? Just let me know. If the video is stopped, am I audible? We'll try it one more time. Okay, if the video is causing issues with the network, I'll stop the video and I'll continue the class without video. I think video is taking a lot of network, and because of which the voice quality is reduced. Okay, we'll try it for 5 more minutes. If it does not work, we'll stop the video. Okay. So is it clear? So like, do you understand the nature of being hydrophilic and hydrophobic? Okay, I think so the video is an issue here. I'll stop the video. Yeah. Is it clear now? Is my voice clear now? So yeah, we understood this. The video is causing the issues. Okay. So the hydrophobic layer and the hydrophilic layer. Okay, this is what you see in the cell wall. Cell wall has two lipid layer. Okay, in the lipid bilayer, one part, the upper part and the end part attracts water, but the middle part, it repels water. So what happens because of the presence of both attraction and repulsion? What happens? Water cannot easily pass through and through the cell wall or the lipid layer. Lipids won't allow that. Okay, lipid won't allow the water to easily come out and go out of the cell wall. They repel water. Lipids will repel water. So because of this, there is a cell membrane permeability. Do you understand that? There is a cell membrane permeability. Membrane, cell wall is very selective about what should enter the cell and what should leave the cell. Okay, is it clear now? Is the concept clear of what exactly the lipid layer, lipids or fats can do at a cellular level, at a cell membrane level? Is it clear to all? Please reply in the chat box. So this is what a fat layer or a cell can do. Sorry, a fat layer or a lipid can do at a cellular level. Okay, they control the permeability. They control what should enter the cell, each cell. Okay, and what should leave the cell. Okay, so this is because of the presence of lipids. This is the phospholipid bilayer. Okay, phospholipid bilayer. The phosphorus layer part of it will attract the water, but the lipid part of it will repel the water. Okay, so this is just a cross section, just a small cross section of what a cell wall looks like. We have drawn it in an animated form. Okay, but is the concept clear? So this is how lipids at a cellular level also how it is helpful for your body. So classification of lipids: simple lipids, compound lipids, derived lipids. Okay. Simple lipids, these are like esters of fatty acids with certain alcohols, and they are also called as fat, oil, waxes. Okay. All the vegetable oils, they come under this category. Ghee, butter, they all are simple lipids derived from plants. Okay. Waxes also comes under the simple lipid category. Oil when it is liquid, while fat is solid. Okay, oil will always stay in the liquid state at whatever degree. Okay, but fat, they will solidify. Okay, fats will solidify at lower temperature and they will liquefy at higher temperature. That is the difference between fats and oil. Like butter. Okay, butter, ghee. Am I audible to all? Am I audible to all? Is my voice clear? Am I audible? Yeah. So lipids, simple lipids, fats, oil, waxes. Okay. What's the difference between fats and oil? Oil will stay in the liquid form even at lower temperature. Any temperature, oil will stay in the liquid form. Fats will get hard. It will solidify. Fats will solidify at lower temperature. Okay. Oils will not. The main difference between oils and fat. Waxes, they are also esters. Okay, they can be divided into true waxes, cholesterol, vitamin A, carotenoid, vitamin D esters. Okay, these are simple fats, simple lipids. Okay, they are also different forms of esters. Okay, basically all lipids are esters. Esters is it's a chemistry name of and another chemical name for lipids. Okay, you don't have to go into the detail of it. So you understand what is the difference between fat, oil, and waxes. They come under simple lipids. Okay. Compound lipids, they undergo they undergo hydrolysis. Okay. And hydrolysis means what? Breakdown. Okay. Hydrogen part, the hydrogen atom in this chemical structure, in its organic structure will break down. Okay. When these compound lipids undergo hydrolysis, they will give another substances in addition to fatty acids and alcohol. They will not just give lipids and alcohol, but they can give another thing. Okay. For example, let me break down 1 minute. If I break down phospholipids, let's imagine we are breaking down phospholipids. What are things you will get from here? Let's imagine a phospholipid is undergoing hydrolysis. From the name itself, what do you think? What else can you get from this? Yes, you will get an atom of phosphorus, and then the remaining fatty acids are lipids. Okay, phosphorus and lipids. Okay, so let's break down glycolipids. What will you will get from glycolipid? Glucose and lipids, glucose and fatty acids. Sulfolipids. When you break down sulfolipids, what you will get? Sulfur and lipids. Sulfur and lipids. So this is what compound lipids are. Compound lipids, when they undergo hydrolysis, okay, compound lipids, when they undergo hydrolysis, they give you more things. Okay, they give you the lipids and fatty acids, but along with that, they give you some additional other compounds as well. So that's the reason why it is called compound lipids. Am I audible? Am I audible? That is a network issue. Okay, some part of it is network issue. So when the video is uploaded today, okay, video will be clear. Whatever you have missed, you will understand in the video. Okay, because if I keep repeating what went off in middle, I will not understand from what part my voice was breaking. Okay, but this video is clear. It is not, my connection is not lost, so the video will be clear. The one that will be uploaded in the YouTube channel, it will be completely clear, so you can get what you have missed from that part. Okay, is it clear to all? Next, we have derived lipids. See, the examples of phospholipids are given like lecithin, cephalin, plasmalogen, sphygmomyelin. These are different forms of um, plasma membranes, cell membranes found in different parts of your body. So different phospholipids are found in different parts of your body. Glycolipids are found in your brain, cerebrocytes, gangliocytes, okay? The nerve cells, they have glycolipids, okay? So, and so on. These are the different compound lipids found within your body. Then we have derived lipids. Okay, these are substances. They are liberated during the hydrolysis of simple and compound lipids. Okay, for example, as I mentioned, when compound lipids was getting broken down, there were certain items that were getting freed off. Okay, so what are these items? What are getting freed out of the compound lipids or simple lipids when they undergo hydrolysis, when they undergo breakdown? Certain things are freed into the system. Okay, they break off from the main structure during hydrolysis, and they are free to form other things. So these are called derived lipids. Okay, alcohol, all the fatty acids, because see, remember here, phospholipids, when we broke it down, we got phosphorus and we got fatty acids. Okay, phosphorus is one compound, but the remaining fatty acids, this is derived, right? This we got from some other compound lipid. Okay, so it is called derived lipids. So fatty acids that you get from breakdown, whatever hydrolysis is taking place within your body, whichever lipids and fats are getting broken down within your body. Okay, so whatever fatty acids are being released from your body, okay, they are called the derived lipids. Then we have sterols. Sterols form the cholesterol. Okay, sterols also lead to the formation of hormones within your body. Okay, then we have isoprenoids, terpenoids, carotenoids. Okay, carotenoids, you must have heard of it. Beta carotenoid, vitamin, it's the plant derived vitamin P, vitamin A. Okay. So is the classification clear? How many different types of lipids we have within the body? Simple, compound, simple lipids we get outside the body. Waxes are present in the body. Ear wax is a form of simple lipid. What is derived lipid? What is compound lipid? Is it clear to all? Whenever the compound lipid is getting hydrolyzed, okay, we get one compound and we get more fatty acids. Okay, broken off fatty acids. This broken fatty acids, which are free to form other agents, are what we call as derived lipids. They are one of the examples of derived lipids. Okay. Coming to chemical composition, triglycerides. So they have three glycerol and three fatty acids. Glycerol, it's see these all are at chemical level. Okay, those who are from a non-science background, you will find it difficult, but just understand how these names came into existence. Okay, so the triglycerides are also esters means combination of glycerol and three fatty acids. Since we have three fatty acids, since three fatty acids are used, okay, since three fatty acids are used in the formation of triglycerides, it got the name of triglyceride. Okay, glycerol plus three fatty acid gives you triglyceride. So they are these are the main form of fat, okay, the different form of fat which you get from your food, okay, and in the storage depots of majority of your animals, okay, animal fat, plant fat, everything can be grouped under triglycerides, okay, and they contain various mixture of fatty acids. This is just one mixture they have shown you, but different types of fatty acids. For example, the fatty acids you derive from phospholipids. Okay, that has a different energy, that has a different theme. Okay, the fatty acid you derive from glycolipids have a different theme. The fatty acids that you got from sulfolipids, they also have a different theme. Okay, so they form different combinations and permutations within your body. These are triglycerides. Glycerol, this is one glycerol compound. You can see here, this is the carbon structure of a glycerol. You add three fatty acids into it, you get triglyceride. Okay, three esters of glycerol. So every plant-based oil, animal fat, they all have triglycerides. Even within our own body, we have triglycerides in different permutations and combination. Okay. R could be any compound. Okay, any compound. Fatty acids. Now, what are fatty acids? We are talking about this part, only this fatty acids. Okay. So we have two different types of fatty acids, saturated fatty acids, unsaturated fatty acids. Which do you think is good for your health? Which type of fatty acids do you think is good for your health? Unsaturated fatty acid is considered largely good for health, but it doesn't mean that you have to completely avoid saturated fatty acids. Okay, both are equally required. Both are equally required. Your body itself makes a lot of saturated fatty acids. Majority of the animal fat is also found in your own body. Okay, so that is saturated fatty acids. So your body also makes a lot of saturated fatty acids in the form of animal fat or human fat. Okay, but both saturated fatty acids can be good for you, but if you know how to limit it, you know how, if you learn how to limit it, how to use it in moderation. Okay, for example, even in Ayurveda, a majority of your medicine preparations are done in ghee base or coconut oil base. Okay, so there is a reason why it is, because why only ghee is used in specific preparations of Ayurvedic medicines, because they can transport the medical qualities in the herb well within the body. Okay, because the same saturated fatty acid is found within human body as well. Okay, so do you understand the yeah, definitely saturated fatty acid is better suited for person who has a family history or who is presently suffering from various cardiac disorders, high cholesterol related disorders, high blood pressure related disorders. In that scenario, try to avoid saturated fatty acids as much as possible. But okay, if you do not have a family history of these disease conditions, this lifestyle-based disease condition, you can still use saturated fatty acids in moderation. Okay. So examples of saturated fatty acids, what do you think comes under saturated fatty acids? Saturated fatty acid. Butter, ghee, coconut oil. Saturated fatty acid is found in milk. Okay, milk also has fat, and the fat found in milk is saturated fatty acid. Okay. No, avocados don't have saturated fatty acids. Avocados have unsaturated fatty acids because it is largely plant-based. Some of the vegetable oils like peanut oil, okay, they are slightly higher in saturated fatty acids, okay. Otherwise, majority of your vegetable oils are seed oils, olive oil, okay. Even fish oil comes under, even if it is an animal source, fish oil comes under unsaturated fatty acid, okay. Sunflower oil, soybean oil, cottonseed oil, safflower oil, canola oil, mustard oil, okay. They all come under. Egg yolk is saturated fatty acid. Animal meat, egg yolk is saturated fatty acid. MUFA and PUFA, that is medium. MUFA means mono unsaturated fatty acid, and PUFA means polyunsaturated fatty acids. Both are good for heart patients. For example, when we say coconut oil is a saturated fatty acid. Okay, you can see the difference. I haven't explained the difference between saturated and unsaturated. See, in unsaturated fatty acid, you have this double bond. Okay, so tell me which kind of cholesterol is good for health? HDL or LDL? High density or low density? High density. High density means it is longer in structure. Okay, so this double bond here, what do you think? If you remember the basic chemistry, the double bond here, is it easier to break during hydrolysis or is it difficult to break? Double bond, I'm not talking about single bond. Double bond, is it easier to break or is it difficult to break? Double bond in any carbon structure. It is very difficult to break. Double bond is difficult to break. During hydrolysis means you are breaking off the hydrogen from the compound, whatever compound is given, hydrolysis. Okay, so double bond structures are very difficult to break. Okay, single bond structure are easy to break. So among this saturated fatty acid and unsaturated fatty acid, which do you think will break down easily when they undergo hydrolysis within your body? Saturated. So this long chain of saturated will become low density because it has broken down into various many parts. It becomes low density. It has become into smaller and smaller parts. It becomes low density. And automatically it turns bad for your health because it has LDL cholesterol. Specifically, you have too much of ghee or butter, animal product. Okay, animal products will only have cholesterol. Coconut oil does not have cholesterol. Okay, animal products can only have cholesterol. So saturated fatty acids have undergone hydrolysis. They have broken down from big chain to small chain. They have become low density and now they are bad for health. But unsaturated fatty acids, they don't easily break down. They remain in the long chain. They remain in the high density. Okay, they have many long carbon structure. So they automatically are, comparatively, they are better for health. Is it clear why we call HDL cholesterol better, HDL lipids better as compared to LDL. At a hydrolysis level, how this differentiation came. Okay, so that's what you have to understand about fatty acid. Okay, about saturated, unsaturated, LDL, HDL. This is what you have to understand. Don't go beyond this. Don't go beyond any technicalities. This is the basic concept of saturated fatty acid, unsaturated. Why is saturated bad and why is unsaturated good? Why is LDL bad? Why is LDL bad, HDL good? Okay, this is the basic concept of it. Okay. Then we have medium chain fatty acid. So this is where the conversation of coconut oil comes into picture. Okay. Coconut oil is a medium chain fatty acid. And what do you think about medium chain fatty acid? Is it good for health or bad for health? They are good for health. Okay. So in medium chain fatty acids, the length of it, okay, the length of the medium chain fatty acid will have around 6 to 14 carbon compounds or 10 to 14 carbon compounds. Okay, that is the reason why we call it medium chain the medium chain fatty acid. Okay, so they are short enough to be soluble in water. Okay, means to break down through hydrolysis, and they require very less pile salts for solubilization, and they are long enough so that they don't cause any plaque formation or atherosclerosis. They don't lead to plaque formation sooner. Okay, this is the reason why MCT oils are referred. Okay, people usually physicians tell you about MCT oils. MCT oils are better for your health, specifically those who suffer from any immunodeficiency syndrome or any malabsorption syndrome, cancer. Okay, for them, clinical oils which are rich in MCTs are used for these patients. Okay, and natural MCTs occur in milk fat as well, coconut oil, palm kernel oil, which we have discussed right now. They have saturated fatty acids and they are bad for health. Okay, but they also tend to be MCTs, and in some or the other way, they are good for health. So there is nothing called evil and good. Okay, there is nothing called good and bad when it comes to fatty acid. It completely depends on moderation. MCT means medium chain fatty acid. Medium chain triglyceride. Triglyceride means fatty acid. Okay, medium chain triglyceride or medium chain fatty acid. Both are the same. Coconut oil is an example of MCT. Milk fat is an MCT. Palm oil as well. So is it clear to all? Now coming to the fats in body. People who have cholesterol, who are diagnosed with cholesterol, okay, it's better they avoid ghee, butter in large quantities. On a daily basis, they have to definitely avoid ghee, butter, coconut oil as well. Eating everything in these kind of fats has to be avoided. Add more vegetable oil. Substitute majority of your animal fat, coconut oil with vegetable oil. This is what we prefer. Okay. So fats in body. First is your phospholipids. Phospholipids we have discussed. This is what makes up your cell membrane. Okay. Each and every cell membrane of yours have this phospholipid layer. So phospholipid layers, they are the ones who regulate your cell membrane permeability. This layer decides how much water will enter, how much water will leave the body, leave the cell. This is what the phospholipids will decide. Okay. They also participate in the absorption of fat from the intestine, because the intestinal cell layer, enterocyte, they also have this phospholipid layer. Okay. So even the nutrition, the fats, okay, and other vitamins, they also have to go through this permeability. Enterocyte should give the permission for these nutrients, vitamins, minerals, carbohydrates, these things to enter into the enterocyte and then be transported into the intestine, uh, into the bloodstream. So those who have fatty liver, alcoholic or non-alcoholic fatty liver, okay. No, phospholipid layer is not the reason why people sweat, okay. The sweat rate is completely dependent on how much water you have within your body, okay, and how much heat is produced in your body during any physical activity, and also environmental factors like seasonal changes, hot and cold environment, okay. These are the reasons that can control your sweat. Phospholipids are not active because your sweat glands, you have sweat glands within your body. Sweat glands produces sweat, okay. So people who have fatty livers, they can eat food that are rich in phospholipids. There is a lot of, you can search Google about it. A lot of food are rich in phospholipids. So those who suffer from alcoholic or non-alcoholic fatty liver, they can focus on phospholipid based diet. Eggs, liver, lean meat, fish, shellfish, cereal grains, oil seeds. Okay, these are some of the examples. So this is one of the fats that is found in the body at cellular level. Okay, then we have cholesterol. So in cholesterol, these are sterols, animal cholesterol, plant cholesterol. Okay, you have mycosterol, ergosterol. These are different types of cholesterol, but in human body, you will find cholesterol. Okay, only animal sources can give you cholesterol. Plant sources cannot give you cholesterol. Okay, so cholesterol occurs exclusively in animal and human tissues, and it is widely distributed throughout your body. And it is a major component of your cell membranes and lipoproteins. This cholesterol is required to a healthy degree. Cholesterol is required so that your body can produce hormones. Okay, there is various other functions that cholesterol has to do within your body. But when your body has more than required amount of cholesterol, that's when you get heart diseases, vascular diseases, high blood pressure, and so on. Okay. About 14% of your gray matter in the brain is made up of cholesterol. And a big amount of cholesterol is also present in the sebaceous gland. Just like I mentioned, you have sweat glands under your skin. You have sebaceous gland also under your skin. So sebaceous gland will produce sebum, the oil that your skin produces to keep it moisturized. Okay. So the sebum is also produced because of cholesterol. And it also serves as a precursor for formation of bile acids, bile salts. For your liver to make bile acids, cholesterol is required. It is also essential for maintaining membranes of the body. Okay. Formation of steroid hormones like estrogen, androgen, progesterone. Cholesterol is required. And cholesterol is completely absent in plant food. Vegetable oils do not have cholesterol. Okay, only in human diet, cholesterol is obtained from ghee, butter, cheese, milk, curd, egg, all the flesh-based food, organ meats, fish, prawns. Okay, they give you cholesterol. Plant food, plant-based diet can never give you cholesterol. And it is not essential. Okay, cholesterol is made within your body. Human body can also make cholesterol on its own. So you don't require cholesterol from any other animal based sources. Your body can prepare its own cholesterol. Okay. Next we have ketone bodies. So ketone bodies, am I audible to all? Am I audible to all? Okay. So next we have is ketone bodies. So when your body does not get enough amount of carbohydrates or glucose, what will happen? When you do not give your body enough amount of carbohydrates. Yes, the body fat is broken down. The body fat undergoes hydrolysis. Okay, energy requirements completely comes from breaking down the fat in your body. Okay, proteins are the last resort. Okay, your body will not go and break down the protein first. The body will go and break down the fat first. Okay, then they will, even when the fat stores are getting depleted, only then the protein, that is your lean protein present in your muscles, they get broken down. Okay, so during this breakdown of fats, okay, when the hydrolysis of fats are taking place, ketone bodies are released. Ketone bodies are the byproduct of the breakdown of fatty acids. Okay, so these fatty acids, broken down fatty acids that are present in your liver, okay, they break down to give acetyl CoA. Where have you heard about acetyl CoA? If anyone remembers, if anyone understands what acetyl CoA is, and where will we use acetyl CoA? When fatty acids are broken down, they give you acetyl CoA and ketone bodies. What is the use of acetyl CoA? Those who are, it's a coenzyme. It's a coenzyme. Acetyl CoA is required for energy production. Acetyl CoA is required for energy production. Okay. So when the fatty acids are broken down, it gives acetyl CoA, and then we get ketone bodies, and these ketone bodies are released into the circulation. Okay, even people who suffer from diabetes, they do not, their body is not able to take carbohydrates and glucose because they're insulin resistant. They are not, their cells do not know what to do with glucose. What their bodies will do, they will go and break down the fats. Okay, and too much of fats are getting broken down in a diabetic patient's body. Okay, ketone bodies will be the byproduct. Fatty acids, that is fats, are getting broken down for energy, and ketone bodies are the byproduct. Too much of ketone bodies in the circulation. Okay, through urine it will be passed out, even through your breath. Okay, you will have a fruity breath. Your odor, your breath will have this distinct smell. It will have a fruity breath. That is because of ketone bodies. Okay, and these ketone bodies will go and deposit itself in the brain as well. Okay, so when the ketone bodies are going and depositing themselves in the brain, that's when you get neuropathy, retinopathy. Okay, all different forms of disease conditions will start from there. Okay, so do you understand what is ketone bodies now? Even in those who are in keto diet, this is the same situation that is happening in your body. Those who go on keto diet, ketogenic diet, this is the same mechanism that is taking place within your body. So ketosis, when your blood circulation has too much of ketone body, you are uh, you are excreting a lot of ketone bodies. Yes, it will affect your kidneys as well. It will affect the kidneys as well in the long run. Okay, lot of ketone bodies are getting filtered out of your urine. Okay, sorry, out of your kidney through urine. It is getting out. So your urine also has high amounts of ketones. Okay, your breath, even your breath has ketones in it. It smells like fruity. It has a fruity odor. Okay, your blood circulation has high amount of ketone. Okay, ketonemia. Your brain cells are getting deposits of ketone. So in this situation, your body goes into the stage of ketosis, ketoacidosis or ketosis. This is how acidosis, it is acidic in nature. Ketone bodies, they change the pH of your blood. Okay, it makes the blood pH more acidic in nature. Okay. Next, we have brown adipose tissue. So brown adipose tissue, it is involved in metabolism, particularly when a lot of heat generation is required in the body. It is active in normal humans, but it is absent in obese people. Okay. Because obese people, they already have a very good insulation of fat over their bodies. They don't require much brown adipose tissue. But in lean people, in active people, lean people, brown adipose tissue is present so that it can generate heat, it can retain heat, keep the body warm. Okay. And what is the character of brown adipose tissue? How is it different from white adipose tissue or pink adipose tissue? Am I audible to all? Yeah. The basic difference is the brown adipose tissue they have at cellular level, brown adipose tissue, they have high amount of mitochondria. They have more quantities of mitochondria. So what is mitochondria? What do they do? They produce energy. It's a powerhouse of the cell, mitochondria. Why it is a powerhouse of the cell? Because this is where energy is produced. Mitochondria is where energy is produced. Okay. So when you have too much of brown adipose tissue, automatically your metabolism is high. Automatically your metabolism is high. Okay. You do not have to be obese. You do not have to put on much weight to get to generate heat. Okay, your metabolism is high, your body is making enough amount of heat to regulate itself. Okay, so that is brown adipose tissue. So it is responsible for controlling the body temperature even in cold weather. So based on the mitochondria activity, who will have more brown adipose tissue? Is it females or males? It is males who have more amount of brown adipose tissue, not females. Females have a separate kind of adipose tissue, which white is present in everyone, but there is one more in females. We call it as the pink adipose tissue, which is utilized during pregnancy and lactation for energy requirements. Okay. Males, it is naturally in males, they have more brown adipose tissue compared to females. So fats in food. Trans fatty acids, completely avoid them. Okay. Excuse me. Stress hormone have different effects. We do not have to go in detail regarding that. Okay. Just understand what is brown adipose tissue. Much detail is not given in the textbook, so you don't have to go there. Okay. So trans fatty acids. These are also naturally occurring unsaturated fatty acids, but trans fat is not at all essential in your body. Okay, they do not have any benefit to human health, so it is not at all required. At the same time, these trans fatty acids, they can raise your cholesterol to the same extent like any other saturated fatty acids. Okay, so they can increase the lipoprotein levels, thus raising the risk of cardiovascular diseases or chronic coronary heart diseases. Okay, so completely avoid trans fatty acids. So from where do you get trans fatty acids? All the processed food. Okay, all the processed food, they have trans fatty acids. Meat and dairy products also has trans fatty acids. Okay, these are not harmful as industrialized fatty acids. The trans fatty acids which is found in meat and milk, comparatively, it is not that harmful as compared to processed food. Okay, you take any packaged food, they have trans fatty acid. Any packaged food, Lays, chips, okay, any biscuits, cakes, okay, they all have high amount of trans fatty acids. Then we have isoprenoids. Isoprenoids are usually steroids used in membrane component, okay, and hormone productions as well. Okay. So isoprenoids, they are they are mainly active in the formation of hormones in human body. Okay. They are mainly active in the formation of membranes, cell membranes as well. Okay, hormones. They are 5 carbon units. Okay. They are all the fat soluble vitamins like vitamin A, D, E, and K. Okay, they all have isoprenoid structure because of which they can be easily carried into inside the human body with the help of fat. Okay, all the essential oils also have isoprenoids. In plant chlorophyll, okay, isoprenoid is found in the form of chlorophyll in plants because of which plants are able to harvest energy. Okay, it is able to take carbon dioxide, convert it into energy. Carotenoids are another form of isoprenoids. Okay, they also have photosynthetic nature. But in humans, isoprenoids are found in steroid form. Okay, helps in the formation of hormones. Also in lipid vitamins like vitamin A, E, K, all the fat soluble vitamins, they have isoprenoid structure. Visible fat and invisible fat. So visible fats are the ones that you buy from the market. Okay, you go out in the supermarket, you buy oils, sunflower oil, peanut oil, groundnut oil, coconut oil, olive oil. You buy butter, you buy ghee, okay, specifically for cooking purpose. These are visible fats. Okay, these are purchased and they are used like fats. Okay, so these are visible fats. Invisible fats are the ones it is present in the food. It is not visible. It is not visible in the form of oil that you purchase from the this market. Okay, but if you are eating a fried food, oil is there. Am I audible now? So visible fats and invisible fats, I hope the difference is clear. Visible fats are the ones you buy from the market. It's visible in front of you. How to use it, you have much control over how much fats you will use, so that how much of it should go into your system. You have much more control with visible fats. Invisible fats, it is already cooked food. Okay. All the fried food, pastries, meats, processed food. You know fat is there, but it is not outwardly seen. Okay. So that is invisible fat. So functions of fat in the body, the must first mean function. It is the essential constituent of the membrane of every cell. Every cell in your body, a cell wall, specifically cell membrane, cell wall, is made up of this fat. Okay. Energy reserve, it gives you 1 gram of fat can give you around 9 kilocalories of energy. 1 gram of carbohydrate can only give you 4 kilocalories of energy. Okay. Fat can give you 9 kilocalories of energy. So it's a great energy reserve for humans and animals. Absorption of fat soluble vitamins. Fats is required for the absorption of vitamin A, D, E, K. Okay, only through fat, only through the presence of fat in the food that you consume, these vitamins can enter inside your intestine. Through your intestine, it can go into the bloodstream, and through the bloodstream, only because of the presence of fat in the bloodstream, it can go to the different organs where it can be utilized. Then regulator, majority of your body functions, because cell membrane essentially is made up of fat. So indirectly, fat is regulating a lot of uh, bodily functions. The flow of materials inside and outside the cell, it's regulated by fat, the presence of fat. Okay. Omega-3 fatty acid, omega-6 fatty acid, they also are precursors to lots of hormones. Okay, enzymes within your body. Prostaglandins, they are also made up of fat. They require fat to be there to be made. Prostaglandins are required in women for regulating the menstrual pain. Okay, so a lot of regulatory functions fat has in your body. Then insulator, we all know it is fat is found beneath your skin in the subcutaneous layer, subcutaneous fat layer, and it gives warmth to your body. It traps the heat within your body so that you stay warm. Okay, so your temperature is warm. Then protector, it protects there is a layer of fat that surrounds your vital organs, around your heart, around your liver, around your kidneys. Okay, a layer of fat is there which protects it. This layer of fat gives the vital organ a cushioning effect. Okay, it protects the entire vital organ as a cushion, so that if at all there is any blunt trauma, not sharp, okay, it cannot protect you from the sharp trauma, but if there is a blunt trauma, this layer of fat around your organs can protect it. Then role of fat in diet, source of energy, which we have discussed. Each gram of fat can give you 9 kilocalories of energy, so it's a high energy macronutrient. Satiety value. For example, let's say you eat a bowl of salad, you eat a bowl of biryani. Okay, biryani definitely has higher fat content. In which will you feel full for a longer period of time? A bowl of 100 grams of salad or 100 grams of biryani? Biryani, because it has a satiety value. It keeps you feeling full. Okay, immediately you will feel full even with a salad or with a bowl of salad. But in the long run, after 1 hour or 2 hours, okay, you will feel hungry again with salad. But with anything that is rich in fat, you will feel full for a very long period of time. Okay. Then carrier of fat soluble vitamins, we have discussed dietary fat is required to carry fat soluble vitamins within the body. Palatability, the presence of fat in the food itself increases the taste of it, the taste factor of it, to add more texture or to add different flavor profile with the food. You require fat. Okay. having boiled vegetables or having sauteed vegetables. You will definitely prefer sauteed vegetables because it has a decent amount of fat, which adds into the flavor profile of it. Okay. Digestion of lipids. No lipid digestion can take place within the mouth or in the stomach because lipase is not there. Lipase is an enzyme that your pancreas has to secrete. Okay, so no lipid digestion, no lipid breakdown will take place in the mouth or stomach. Okay, so and also emulsification of fat is required. For that, bile salts are required. So in stomach, you will not have bile salts. As soon as the food leaves the stomach, before it enters that small intestine, that is where lipase and the bile salt, bile juices will be secreted. It will get mixed with the food and the fat will get digested. The fat digestion will start. Okay. In the mouth and in the stomach, no fat digestion will start at any cost. Okay. So the major site of lipid digestion is your small intestine, where dietary lipid undergoes its major digestive processes using enzymes secreted by pancreas and also the bile salts secreted by the liver. Okay, so this is the digestion of lipids. In mouth, no digestion, stomach also no digestion. Lipase is required, which is secreted by the pancreas, and also bile salts are required, which is secreted by the liver. So as soon as the food leaves the stomach, only then the digestion of the fat can begin. So here, this is how the fatty acids, so you can see big globules of monoglycerides. Okay, these are big globules. Now they have to be emulsified into smaller micelles, and this can take place only with the presence of bile salts. Okay, this is what the bile salts in the bile juice secreted by the liver do to fatty acids. Big fatty acids cannot be absorbed by intestine. They have to be broken down into smaller micelles. Okay, so only with the presence of bile salts, this emulsification can take place. Okay, so when it enters the stomach, it is still in this bigger monoglyceride form. Okay, but as soon as it enters the small intestine, it has undergone emulsification. Okay, by getting mixed up with bile salts, and now it is in the micelle form, the small micelle form. Next, these micelles can readily get inside the enterocyte. This is the cell, okay, enterocyte. So the micelles fatty acids, they enter the enterocyte through epithelial cells for the enterocyte and link to form triglyceride. Okay, they link with each other and form triglyceride. Once the micelles are inside the intestine, they are forming triglyceride. Okay, they get connected with the esters, glycerol, and three fatty acids, and they form triglycerides. Single fatty acids are getting inside here, but they form a group of three fatty acid and they form triglyceride. And this triglyceride, they combine with the protein which is found in Golgi apparatus. I guess you remember what is Golgi apparatus. Mitochondria, Golgi apparatus, lysosome, from your basic biology classes in school and all. Okay, so Golgi apparatus give protein. So with the help of this protein, this glyceride can move out of the intestine in the form of chylomicrons. Chylomicrons, we will discuss again later in other classes. Chylomicrons are the major structure which carries vitamin A, vitamin D, vitamin E, K, all fat-soluble vitamins are carried inside chylomicrons, and chylomicrons carry this vitamins to different parts of your body. Okay, so this is how the function, this is how the entire mechanism of fat absorption takes place within the body. So chylomicrons can directly enter into the blood circulation. Okay, so big monoglycerides will be broken down into micelles with the help of bile salts. Micelles are single fatty acids. Okay, micelles will enter the enterocyte, your small intestine. Three fatty acids from the micelles will form triglyceride. Okay, and then they go to the Golgi apparatus, take the protein from there and form chylomicron. And now they are in the chylomicron form. They are ready to move into the blood circulation. They also carry fat soluble vitamins with them. Is it clear to all? The absorption of fat. Is it clear to all? Coming to essential fatty acid that humans and other animals must ingest because body cannot make it. Your own body cannot make essential fatty acid. You have to get it from food sources, other food sources. Okay. So term essential fatty acids refers to fatty acids required for biological processes, but they do not include fat that can act as fuel. You do not require essential fatty acids to give you energy. Essential fatty acids can also give you 9 kilocalories of energy, but that is not the use, but that is not their use within the body. Okay. Do not use essential fatty acids for energy purpose. You have to use them for other biological purposes, processes within your body. Okay. So what are essential fatty acids? Omega-3, omega-6, omega-9 is also present. They are given about it in the textbook. So omega-6 is good, but usually whatever food you have from that, whatever oil you use from that, you get enough amount of omega-6. You are not deficient in omega-6. Omega-3 is good, but you have to make sure you're getting enough. So make sure on a daily basis you eat flax seeds, or at least you have omega-3 fish liver, fish oils, okay, or other sources of omega-3 as well. You have to be focused on this. Omega-3, omega-6, you do not have to focus because your cereals, pulses, different oils that you use in your daily cooking, they all have enough amount of omega-6, but omega-3 is a little bit more rare, so you have to be focused about it. Okay. Specifically, DHA. DHA is docosahexaenoic acid. Docosahexaenoic acid, DHA. If it is a child, if you're dealing with a child who is in the growing stage, okay, DHA is required for children for their vision, health, as well as their brain development, their central nervous system development, and as well as their vision development. DHA is required. Okay. Majority of the Horlicks, Bonvita, Pediasure, with these kind of milk drinks, okay, you see, they target their audience saying that it has enough amount of DHA for the growth of the children. It is necessary. It is, as it is true. DHA is required. DHA is a very essential omega-3. It's a type of omega-3. Also, you have 3 different types: linolenic acid, eicosapentaenoic acid, docosahexaenoic acid. These are different types of omega-3 fatty acid, out of which DHA is a major component of your phospholipids in retinal, that is your eye, and the cerebral gray matter, and in males for the sperm production. DHA is required. Okay. Docosahexaenoic acid. Let's give on the textbook. So general uses, functions of your essential fatty acids: energy stores, but you don't use it for energy. Okay. Immune health, omega-3 fatty acids and omega-6 fatty acids. If you are taking it in a balanced supply, your immunity will stay strong. Specifically, your thymus dependent cells, T cells production and B cells production in childhood, you require it. Then growth and development. Omega-6 and omega-3 polyunsaturated fatty acid is essential for postnatal growth as well as intrauterine growth of the fetus. If the mother is deficient in omega-6 or omega-3, it will affect the fetus's growth and development. And even after delivery, when the child is growing on its own, okay, DHA is required. Vision and central nervous system, specifically again DHA. Okay, you cannot let go of that. DHA is required for womb health during lactation and even after delivery, postpartum as well, to protect the children's eye vision health as well as the central nervous system. In cardiovascular health, omega-3, omega-6 acid can reverse the effect of atherosclerosis if it is in the initial stages. Atherosclerosis means plaque formation. Fats are getting deposited, cholesterol is getting deposited in your blood vessels in the initial stages. If you correct it, if you have good balance of omega-3 and omega-6 fatty acids, you can actually reverse the formation of initial stages of atherosclerosis, not the later stages. Specific mechanism, It can prevent cancer. It has anti-carcinogenic action. Formation of prostaglandin, as I mentioned, prostaglandins, in women's health, prostaglandin is required to control the menstrual pain. Okay, if your body does not have enough amount of prostaglandin, if the body is not making prostaglandins, you will feel immense pain during menstruation, dysmenorrhea. Okay, so if the body is making enough amount of prostaglandins, your uterus is able to relax properly during menstruation, so you will not feel much pain. Your menstruation will be easy. Okay, defense mechanism, that is your immunity. The first defense mechanism, the cell membrane, which forms the lining um, of your intestines, of your throat. Okay, for the health of it, omega 3 and omega 6 fatty acids is required. First line of defense. Then extracellular matrix. It supports not just the cells, but also various organs from the multiplication, development, movement, shape, and biochemical functions of the cells. So not just inside the cells, the area which is outside the cells also, for the health of it, to keep it anti-carcinogenic, omega-3 and omega-6 fatty acids are required. Lipids in the cerebral cortex. Cerebral cortex is a part of your brain. Okay. At least 80% of fats in the brain, lipids in the brain, is made up of omega-3 fatty acid. A diet which is rich in omega-3 fatty acids contributes to a higher degree of intelligence, okay, memory, improves concentration, and also gives mental alertness to the person. Okay. So the deficiency of essential fatty acid, it gives you a keratinosis based disease condition in which your follicles, your skin follicles, it gets keratinized. Keratinized means it gets dry and it gets harder. Okay, dry and harder. That is keratinization of cells. Okay, what happens here is that the old cells are not getting shed off and the new cells are not produced correctly. So what happens is that the old cells will be just dumping up on each other. They will just pile up on each other. Okay, they are dry, they're hard, and they don't fall off. This is keratinized cells. Okay, so the hair follicles undergo this keratinization. This is called phynoderma. Okay, phynoderma is this is condition very rare. Okay, phynoderma is very rare, but when it happens, it is the deficiency of essential fatty acids. Deficiency of essential fatty acids can lead to phynoderma, in which the hair follicles undergo keratinization. Okay. So the RDA of essential fatty acids, omega-6 is to omega-3, should be 5 to 10 is to 1. Means either 5 to 10 parts of omega-6 and 1 part of omega-3. This is the given RDA. So you don't have to worry about fixing this RDA, because majority of the oils that you use, vegetable oils that you use, you get from the market. Indian government has made regulations that certain degree of RDA of omega-6 and omega-3 is met through these vegetable oils. Okay. If you focus on the ingredients part or the content part of the oils, you will find out about this. Okay. Visible fat intake should always be less than 50 grams per day. It completely depends on your activity level. If you have a sedentary lifestyle, your visible fat intake should be less than 25 grams per day. Okay. If you have a moderate activity level, 30 grams can be is completely fine. But if you have a very active lifestyle, very active way of life, okay, 40 grams of fat per day can also be taken. Athletes and all can take around 35 to 40 grams of fat per day. It's fine with them. But if you have a sedentary lifestyle, stay below 25 grams of fat per day. So this is the sources of omega-3, omega-6 and omega-9 fatty acid. You can take a screenshot of it, which you can use later. Good sources of omega-3, omega-6 and omega-9 fatty acids.